Right folks, got a quick repair in today. Hopefully should be quick. These are thermostats that are used in vivariums for like keeping snakes and reptiles. I get a few of these in with various failure modes. Generally, anywhere from the inside is a thyristor that they can go short circuit. It's quite nasty if that happens, because that will keep the heat on the heat mat and it cooks the snakes alive. Horrible way to go. Oh, the other failure mode is the temperature sensors die quite commonly. So let's tear this open and see what's up with it. Well, now it's on the bench. First thing to do, well, before tearing it open really, you should test it, see what's wrong with this one. So they're quite easy to test, and all you really need is a test load, which I use a 15 watt light bulb. It's just fairly low load, like a heat mat would be. What I tend to do is just put the temperature sensor next to the bulb so you can regulate to it. Turn the temperature down on there, turn it on, straight away it's on, full power. Straight away this is a shorted thyristor. Let's get the lid off. These things are commonly just got 4 screws in there. Well, I've just seen this screwdriver doesn't fit that well. That's it, a posi drive this one. So that's over there. Try number 1 posi drive. That's a better fit. Yeah, you normally have 4 screws, and then they tend to be trapped with some glue or some other very cheap manufacturing method. So inside we got a back of the circuit board in this one. Obviously all the actions on the other end of it. And you can just, this one's not too bad actually, you can just bend it up out of the way. This one actually contains a triac, which is a bit different to a thyristor, but for in terms of the way that we repair them, no different at all. This triac is an FT0833MH. We measure the resistance between the 2 legs. On these it sits the left leg and the middle leg. Measure the resistance. Oh, 0 ohms, as usual. Generally speaking, these are pretty, the rest of the circuit's quite hardy. Just change this and away you go. The temperature sensor, which is labelled as the probe on this board, just measure across there. Typically you'll get a reading of about 10k on some of these. It's actually going to be a 100 kilo ohm temperature sensor, and it gets a lower resistance as it warms up. This is measuring on the board 32 kilo ohms, so I'm thinking that's in the right sort of area. Things to check with these thermostat type devices that can go wrong, and they fall into 3 different categories really. The first ones are dead ones. These get their power fed through this capacitor, like a large film capacitor, and typically something like 0.47 microfarads. These will degrade with age and starve the circuit of the voltage it needs to run on. So dead ones, the capacitors are favourite. The next ones are the ones that are always stuck on, getting hot. That is the thyristor or the triac, depending on the design, but the big 3-legged device, they'll go short circuit. And the last failure mode is actually the temperature probe itself. Strangely, they can go like short circuit, so those ones never come on. So you got dead, always on and always off. Those are the 3 modes. This FT08 triac's not that special at all really. It's just an 8 amp triac, 50 millivolt gate. Got a box for the triacs here, a little drawer of them. I'm going to use a BT08 600 TW as well, 600 volt one. It'll be fine, trust me. Let's get some fresh solder onto each of the 3 legs, which helps. That's just like fresh flux on there, helps the heat spread. Get some pliers on the end of the heat sinks. It's going to get quite hot. I find things like this only got a few legs, it's probably easier just to get all pins hot together and just pull it out. Easy job. Now you just get some solder pump or whatever tool you're using, and just suck that solder out of there. They thought about putting a heatsink on this triac to keep it cooler. Now triacs won't get that hot because they don't sort of lose that much energy. This is probably why, because there's no heatsink installed on this, is why they've got an 8 amp triac, but the unit's only rated for the 1.3 amps. But there's a little upgrade should you want to upgrade your thermostat. So just solder this up. Just cut the legs off or fire them across the workshop, as long as they've not landed inside, and we should be good to go. This is actually one of the nicer made ones from what I've seen. This one's not too bad at all. Where those screws and screwdriver. Oh. Like a lot of my repairs, putting the screws back in tends to be one of the worst parts. Okay, this is the test setup. We've got the thermostat, we've got our test socket, which is the 15-watt light bulb. Got a little the temperature probe put next to the light bulb. Just it's got a bit of feedback. Just turn the power on. We can see the power light is now on. We don't have the output now, which is good news. It's now not shorted. So as we turn the temperature up a little bit, now we have the lights come on. You can quickly test it by turning it down. Light goes off. So this is sort of working. You'll see what happens if we get it to just come on. What we can do now is leave that just to warm up, and you'll find that it'll start to regulate, and the bulb will start to dim or pulse depending on how clever this little box is. There we go. It's turned itself off. It's at temperature. To prove it's still working, we can just give it a little bit of a tweak on the knob there. Comes back on and back off. There we go. So that's a nice and easy repair for today. Catch you next time.